Hello everyone again. We are continuing on with 5.3 notes. This is case 3 and 4 we're going to cover today. The first case 3 is about irreducible quadratic factors. That means that instead of linear like it was in case 1, one of the factors at least is a quadratic. And as you can see, we start off by factoring the denominator first. And I show that in factored form, it's x times x squared plus 4. That is not reducible in the real number system. That would be a complex. So we want to keep it in the real number system when we factor these. Then the next item is to start doing our decomp and our variables to represent a constant. Now the difference here is, as I mentioned before in case 1, is that in a polynomial in descending order, whatever the denominator is, it needs to be 1 less than that in the numerator. So for example, with the factor of x, that's linear, monomial, and the next descending order would be just a constant. Hence, that's why we have the a. And then the second factor is x squared plus 4. Well, that's not reducible. Therefore, the next item in order, in descending order, would be an x plus a constant, because this is a quadratic. Remember, polynomials go ax squared plus bx plus c, or quadratics, I should say. Therefore, after a quadratic, x squared, the next item is linear at an x, then a constant. So we have to represent both pieces in the numerator. That's why the bx plus c occurs, where b and x are just numbers. Or excuse me, b and c are just numbers, and x is the linear piece after the quadratic. Then we continue as we did before. We're going to multiply by the LCD and eliminate the denominators. I end up with the result of the numerator on the left-hand side, and then a times x squared plus 4, because the x cancels out. And then the second binomial is going to be multiplied to just x, since x squared plus 4, those will simplify and be 1 or cancel out to be 1. Then we continue on by multiplying it through, and we get our multiplication out in linear, regrouping it. As you can see, I underlined as I did before. With the x squares, I have an a plus b. For just plain x's, I have a c. And for constants, I have just 4a. Let me scroll down. Then let's set up our equations to represent that. So the coefficient on the left is 2 of an x squared, and the coefficient on the right is a plus b. Therefore, I have a plus b equals 2. The second item is our middle term of x, and it would represent a -1. And then the last one, 4a, goes with the constant, which is 4. You can simplify those down, very easy and very quick, and you get your ABCs. After that, we just go back to our step 2 where it's already in factored form. And remember, this is a over x, so a is 1, and this was bx plus c. Well, b is 1, so it's 1x plus c, which is a -1, so it's x minus 1. If you want to put 1 in front of the x, that's fine. It means the exact same thing. And that is our final answer for case 3. Now down in case 4, if the question states that to write the form of the partial fraction decomp, then we're not solving like we did over here and went to step 6. We're just getting through step 2 and 3. So just factoring it into its pieces. Do not solve these. This is a repeated irreducible quadratic. So looking at this one, just like we did in case 2, as x is being repeated 3 times. And I mentioned an item relating to the number 8 in a factor tree. Same thing. So x can be represented by x, by having a factor that's x squared and then x cubed. On the other item over here, the binomial of x squared plus 2, that's a non-factorable or irreducible quadratic in the real number system. So we represent this 3 different ways: as a single, as a squared, and as a cube. And then the middle one, the trinomial, is just to the power of 1, but it's irreducible as well, so we leave it as is. Then we go down, let me scroll here, and you can see I have that to equal. The form is going to be the x, then x squared. Now I can put parentheses there or I cannot, because it's not a binomial, it's a single, it's a monomial. Then it's fine to keep it as is without the parentheses. If you want to put the parentheses there, that's fine. It means the same thing. So this item is linear, so that's why the constant. Now, many students get confused because this says x squared, but what item is being squared? A linear item of x is being squared. Because x originally, just like over here, under the repeats, x originally is linear before it gets squared. That's why the constant is only b on the numerator. Same thing with the third one. It's x cubed. So again, x is originally linear. So linear, the next item in order would be its constant of c. Then we get to our trinomial, which is a quadratic. That means I need to represent the next descending order after a quadratic is an x, a single linear, plus a constant. Therefore, I have to have a number of some sort, dx plus e. That's being a d and e are just numbers, they're constants. And then we're going to go to our irreducible quadratic that's repeated. This, if it helps you to put it in a parenthesis to recognize that is the binomial to the power of 1, but it's originally a quadratic. Because it's a quadratic, the next descending order again is the linear piece and the constant. So again, we have x in here, and I have to have a variable to represent the number that goes in front of x. So fx plus g, f and the letter g are both just numbers in the end. And then we continue on with the x squared plus 2. It again is a quadratic. So we have hx plus I, and then again our binomial is quadratic, being to the power of 3. So it's jx plus k. Thankfully, we're not asked to solve that. That would take several pages of paper to go ahead and do that. So at this time, we're just going to write the form of one of these items. Hope that helps. We'll talk to you later.